Okay, hello, and welcome to another Stats 1 video. I've had some requests in terms of some of the Chapter 4 material, outcomes, events, sample space, probability, and some people have found this a little bit confusing, so plus the probability notation, the rules of probability, and so on. So let's just start with an explanation of outcomes, events. I saw some of the responses to this in the forums, and I think some things need to be cleared up a little bit. So when we talk about outcomes, well, first of all, an experiment. So an experiment So an experiment is something that has an unknown outcome. So this could be, you ask someone a survey question. What's your age? So X is a random variable. X is a random variable because we don't know what value it is until we ask that question, until we perform the experiment. So that's the whole idea of a random variable. Random variable X could be, for example, the outcome of a dice roll. Die. 1 die, 2 dice. So that's why we call them random variables, as I've previously said. So we perform an experiment. Either we ask someone a question, we take a measurement, we roll a die, and that is an experiment. Now an experiment can have several outcomes. For example, I roll a die and I let X equal number of dots, right? So I have 6 outcomes, namely 1, 2, 3, 4, 5, and 6, obviously. Those are 6 outcomes. So an outcome is a simple result of an experiment. So here is my experiment. That's rolling the die. Now, what I can do also is I can take outcomes and group them into events. Now, events, we'll say an event, is a group of outcomes. So again, we'll go back to the die example. I can say event, and we usually use capital letters, typically E, F, P, Q. So I'm going to say event E is roll an even number. So that event consists of several outcomes. It consists of the outcomes 2, 4, and 6. So that's the difference between an outcome and an event. An outcome is a very specific individual result of an experiment, and an event is a collection of outcomes. So I could say, for example, event E, so I'm going to use some probability notation here. Before I do, I didn't cover sample space. Sample space is the collection of all possible outcomes. So in other words, this, I should have just boxed this. This is my, whoa, didn't mean to cross out the 6. This is my sample space. The sample space from this experiment is 1, 2, 3, 4, 5, 6. Okay, so like I said, the sample space is made of all possible outcomes. We can look at another possibility for dice. And if I roll 2 dice, let's say I roll 2 dice, I have 36 possible outcomes, right? Because I have 2 dice, 6 possibilities for each, 6 times 6, so anywhere from 1, 1, 1, 2, everywhere up to 6, 6. 36 possible outcomes. But I can define an event E as, let's say, sum of 5. Well, that event has 4 outcomes. Namely, 1, 4, 2, 3, 3, 2, and 4, 1. 4, 1. So those are the 4 possible outcomes that make up event E. So let's define a random variable, and I'm going to let x equal the sum of the 2 dice. In probability notation, can I a little bit? Because I'm running out of room. In probability notation, I can write this as follows: the probability that x equals 5. Well, what's the probability? The probability is the number of favorable, and I would put that in quotes, because favorable or successful just means what we're looking for. But the number of events that are in our number of favorable outcomes, that's these, of the number of total outcomes. Well, we have total of 36 outcomes. Out of those 36 outcomes, 4 contain what we're looking for, sum of 5. So my probability of rolling a 5 is 1 out of 9. So that's the whole idea of outcomes, events, experiments, and sample space. My sample space has 36 possible outcomes. So this is my sample space. I can take 4 outcomes from that sample space and make up the event sum equals 5, and the probability that sum equals 5 in this case is that 4 out of 36. Okay, so next thing is talking about various rules of probability. But before we do that, there's another way of expressing outcomes and events. If you've seen a Venn diagram, some of you have seen this before, I'm going to let this box is my sample space, and I will put some outcomes in the sample space. Before I do that, I'm going to put my events in first. So my event A, and event B. And so I'm going to put some outcomes in here. Nine. I'll leave it at that. That's a 6. That's not a 69. That is a 6, comma 9. Okay, so I have 9 outcomes in my sample space. If I'm going to draw a number at random from this sample space, so I could say the probability of drawing 6. Well, that would be 1 out of 9 because there are 9 numbers, one of them is a 6. If I could say the probability of event A. Well, the probability of event A here is, well, how many outcomes are in A? Well, 3. 3 outcomes are in A out of the 9. Now, we talk about rules of probability. Rules of probability, we can talk about and or events. You notice I can say, well, probability that an outcome is in event B, well, that's 5 out of 9. Now, what if the probability A or B? The probability that an event is either in A or B. Well, let's see. 1, 2, 3, 4, 5, 6, 7. 7 out of those 9 events are in either A or B, or I can say what's the probability of A and B. Well, how many events are in A and B? This intersection of the Venn diagram says that outcome 3 is in both of these events, and that's the only one. That 3 is the only event outcome in that joint event, A and B. I could say other things like probability of not B, or B with a C complement. What's the probability that an event is, the outcome is not in B? Well, 5 out of those events, out of those 9 events are in B, so the other 4 are not. Okay. So we want to talk about rules, particularly in notation. So I'm going to erase some of this here. Hopefully you have this. It's a good thing about recordings. You can go back and... But I want to preserve this diagram, so I need to erase here a little bit. Okay. Rules of probability. So we have the addition rule. You had a few homework questions like this. We have to figure out an OR event. So a Venn diagram is the perfect way to illustrate this. I'm not going to use this diagram because I want to, so I'm just going to put this, make another here. Let's say I want to figure out the probability of an outcome being in either A or B. Well, okay, so let's tick off everything that's in A and check off everything that's in B. Well, you notice this middle area here, I counted that twice. Can't do that. So I'm going to have to subtract the A and B. I don't know how I'm going to do that here. But anyway, I counted this twice. So I would have to count this, to erase one of the A and B in order to get exactly what's in either A or B, but not both. Okay. I see we're running out of time for this video. So what we're going to do when we come back, I'm going to illustrate some of these rules of probability with a few examples, and we'll talk about independence, conditional probability, and that's it. Okay, so I'll see you in the next video.